to kind of get going, I want to see in this room, how many people have actually heard of Alluxio? Okay, maybe 10%, maybe not that high. That's good. So you're going to learn some stuff here about Alluxio. And then another question I had was, how many people either are desiring to or are actually already like running Solr like in a cloud, like EC2 or Google or something? Okay, cool, very nice. All right, so for today, I'm going to give you a little bit of overview for Alluxio. It's well documented, and so I won't spend too much time on like the internals or anything like that. I'll just cover some of the main features that are particularly interesting for Solr, and then I'll talk about a little bit kind of just the basics of running Solr on Alluxio, and then we'll get more into kind of why you'd want to do that, what's interesting about it, and that sort of thing. And then these are early days for running Solr on Alluxio, and actually for Alluxio in general. So I'll talk about some futures and some issues I found, and some things we want to probably would do in Solr, and those sort of things. And we should have time for questions at the end as well. Okay, so trying to get started, just kind of just pique your interest. Like, it's awesome. Only a few people have heard of it, but it's actually in the big data space, the like most sort of fastest growing, most active. I think their last release had 175 unique contributors. And you can compare like Spark is a really active project, and they're, in terms of contributors at Alluxio, like way more than Spark even. So I thought that was actually pretty cool. Another thing is, company Baidu, they actually saw a little presentation about them. They have an Alluxio cluster with 1,000 nodes and 50 terabytes of memory that they run jobs on and things. And that was in February 2016. So who knows how big it is now, but like people are actually doing very massive scale with Alluxio already. And typically that's like powering Spark jobs and things like that. But for me, I think I was actually at a Spark, maybe a Strata or a Spark conference, and I first sat on my first talk about Alluxio. Back then it was called Tachyon. And I started thinking, you know, being in the Solr community, I'm like, I wonder if we could run Solr on this, right? And because it seems, and as we'll see in the talk, there's some pretty desirable properties that we get by running Solr on this. And one of the main ones really is this sort of bringing cloud storage, basically allowing Solr or your compute jobs and things like that to sort of run on and use cloud storage, but actually without giving up sort of the speed that you need. And we'll see how Alluxio does that. And just need 1 second. Like my view of the slide is like too small. Okay, that's why I keep looking up there. The other thing is, and I think this is pretty cool, but some people probably have seen this problem or have this problem. It's like, well, I have 50 terabytes over in S3, right? And then maybe 100 terabytes on some network attached storage device or whatever, right? Alluxio, basically, there's no moving of data. You don't move the data into Alluxio. What's cool is you actually just mount what they call an under file system into Alluxio, and now that storage is basically visible and in Alluxio's file system, and actually now allows you to use it with Alluxio. So there's no moving of big data here, which I thought it was actually pretty cool. It's not an Apache project, but it is Apache 2 licensed, and they also have the, you know, the sort of the community version as well as the enterprise version. As far as I know, the enterprise version has a few extra bells and whistles, kind of how we all do this stuff. But what I'll show you today is all just off the commercial version. So, what is Alluxio? Basically, I like to think of it as kind of like a HDFS. It's a distributed file system. And when you look at the Alluxio docs, they call it memory-centric, because if there is memory available and you've allocated it to Alluxio, then what's going to happen is it will prefer to hold the files in memory. And we'll see there's actually some very nice controls about, like, you can say, you know, this product index is very important. Let's make sure it stays in memory, whereas maybe a logs collection or whatever, not as important. That can fall down in this tiered storage mode that they have. Okay, and then as I mentioned, like Baidu, you can have single node, right? And, or it can scale up to massive clusters, right? And we already saw like 1,000 nodes, and again, that was a year and a half ago, so who knows what people are up to. For the Solr folks, it's pretty cool. They use Zookeeper as sort of a master model where you have a like a kind of active model and then one in standby using Zookeeper. So if the active one drops, then a standby will take over as the master. So it uses Zookeeper. So it's all nice kind of stuff that fits well with the Solr community as well, right? We're all very used to running Zookeeper and those sort of things. And then the thing I like about it is, as you see in the diagram, like all these different cloud storage and file systems and those type of things, and it seems like one comes on like every month, right? There's a new cool file system out there. The awesome thing here is that Alluxio basically hides all that from your computation layer, right? The stuff on the top here, Spark and Flink, and as we see Solr now, I'll talk through that. But yeah, so basically all the computation, Solr, Spark, they go through Alluxio, and they don't actually know they're dealing with S3 or Google Cloud Storage or whatever under the scenes. So that's a really nice thing that you can have. I don't know if you'd want to do this, but you could have some of your indexes out in S3. Maybe you don't care about them as much. They're really big, right? And then you have some of your indexes out on like an NFS. And if you've been around Solr a lot, the question always comes up, like, can I run Solr on an NFS? And everybody's like, it's usually not good. It doesn't work quite right or whatever, or these type of things. Now with Alluxio, you can actually do that, which I think is pretty cool. Okay, so that's sort of the high-level view of Alluxio. I'll have time for questions at the end, so if you want to know more about it. But actually, I think just go to the site and download it. And if there's time, actually, I can fire it up and show the UI and those sorts of things. But let's talk about now kind of just getting started if you want to run Solr to use Alluxio, right? And actually, one other question I had for folks, who in here is running Solr on HDFS, if anybody? You? Okay, cool. Interesting, because that's actually a pretty cool feature of Solr, and it actually has some nice things like auto-add replicas. If you lose a replica, you obviously haven't lost the storage, so the overseer can ramp up a new replica and that kind of thing. So I've liked the architectural story around running Solr on HDFS, but it was always actually a little bit too much overhead, and it ended up being slower. You actually wrote auto-add replica, didn't you? Yeah, oh, okay. All right, I knew you had something to do with it. So what we're going to do is, when you first get going, you need to essentially make a directory in Alluxio, and out of the box, if you just bring Alluxio up, it will use the local file system as it's under FS, right? But as I said, you can also mount, say, S3 behind the scenes as a directory in Alluxio, right? So in this case, we're going to just basically make a Solr directory off the root, right? And that's where we're going to store our indexes. The next thing you kind of need is to set up this HDFS directory factory. So what's nice is Solr already comes out of the box with all the code to actually leverage Alluxio. We just use the HDFS directory factory, sort of written and maintained and loved by Mark and Yannick. So you have a couple options here. I don't like putting the directory setting in bin solr.sh, because then now, like, all of your indexes, I say all of your collections have to use that. So I actually like to keep those out into like a config set, right, that you'll load into Zookeeper. But it's your choice. You set those up. Now, lock type, you have some choices here, and I'll talk about problems, but we're using HDFS, so we'll use the HDFS lock type. I ran into some problems with that, but we'll talk about that more. The next is we will actually want to set the HDFS home. This is a property that essentially in Solr, when you set that, it will kind of use that as its entry into the file system in HDFS, or in this case, Alluxio, and then it'll start creating indexes and all that under that root. So you basically just point to the Alluxio master, who kind of controls, it's kind of like the name node in HDFS. The master knows like all the, basically, locations of the workers and these type of things. So you set that up, and then lastly, since this is Hadoop, and we're actually going to use the Alluxio Hadoop API, you have to pass a path to the Hadoop core-site. And the things that are in the core-site, and I'll actually just pop over really quick. I should mention, I did a gist for this. I think I linked to it. Yeah, so that on my slide, the little bit.ly link will take you here, and that, so you can copy and paste and get rolling. As you can see, it's very quick. But in core-site, you have to set up a couple things. First off, Hadoop has this sort of pluggable way to plug in file systems, like, and so we're going to plug in the Alluxio file system, and then Alluxio in their code, they provide this Hadoop implementation. They also have REST API and all these kind of other APIs, but since Solr already supports HDFS, it's best to just go ahead and use this one. Let's see, this guy here, and I opened a Solr ticket about this. So when you do things with the Hadoop API and you call file system get, you're not supposed to close that object, but whoever wrote that code, like I don't know what they tested with or whatever, it's different on different file systems. But you have to turn this off so that basically you get a new object and you don't use the cache, because basically Solr was behind the scenes closing file system objects incorrectly. So you've got to set that. This cache through, I'll talk through in a second. And then actually this one I can take out. Once you move to Alluxio 6, there was a bug I found. I think like a week ago, I didn't have any of this working. And then it was like, oh, there's a bug in Alluxio. They fixed it in 1.6, so no big deal. We can take that one out. Actually, and while I'm here, I'll just bring this up. This is their little UI. Kind of feels like a lot of the Hadoop UIs and things like that. You can see I'm not using much of my space, but I have mounted, remember that command I showed to make the Solr directory? That's here, and then I have an index in there. It doesn't have any data. I figure you guys trust me on indexing data into Solrworks. And then also I have mounted out here my S3 directory, right? And I have some data out there as well, right? But to the Alluxio client, it just goes through Alluxio. It doesn't matter, again, that it's in S3 or local or what have you. Okay, so back to this. Oh, you guys saw my iTunes. Country music fan. Okay, so now you've set up the core site, and there's some basic settings there. And then, of course, you have to copy the Alluxio jar into the Solr class path. And unfortunately, with Solr 7, I just tried this out, AB, that jar has Coda-Hail metrics in it, but it's incompatible. So I'm going to open a ticket against Alluxio to actually have a shaded all dependencies jar that they ship instead of just competing dependencies. Java and its class path dependencies, right? And then lastly, as I said, I don't really like having the the directory factory set like globally in the bin solr.is. I like to keep it actually in a config set. You don't have to do that. If you just want to do all Alluxio, then you don't have to have a special config set. But if you do, you'll love that. And I'll mention one other thing down the road, like if you want to use the HDFS update, the T-log through Alluxio, it definitely works, and you need that for auto-add replicas, but it has code that basically says, is the URI HDFS : and it's not, right? It's Alluxio : So you actually have to set the class for the update log. So that'd be another reason why you have the config set. Okay, so now let's get to, so that's the basic config. Like I said, there's a gist out there. You can get this up and running very, very quickly, following those notes. And actually, I got pinged on LinkedIn. Some people found this talk somewhere out on Google or whatever, and are like, hey, how does this work? And so I wrote up that gist, actually, and I've basically heard these people got it up in minutes, which is pretty cool that it just works. And on the flip side, I tried to do, because I want to do a performance comparison, and this is one of the things I think is cool about Alluxio, is I could not get Solr's HDFS stuff talking to S3 using the S3A protocol working. Again, another class path problem, right? And so the nice thing is like Solr just works with Alluxio, but if you're trying to go directly at S3, it didn't work, right? And this is kind of, I've seen it out on the web, like people run into this problem, and again, it's more class path headaches. So it's kind of nice that it's like Solr gets insulated with Alluxio from a lot of these underpinning file system problems, right? Which is kind of cool. So if I'm doing this, I would run an Alluxio worker on each Solr node, and that Alluxio worker is going to be the thing that actually takes memory from the system and holds it away from, you know, for Alluxio, for storing files in Alluxio, talks to the master and all those kind of things. But so when Solr is running on you want one on each node, so that way you get kind of data locality, and Solr is hitting the actual worker local to it, so you are doing memory speed. Another thing is the write mode is cache through, and what that basically means is when you do a write, say from Solr, say it's writing a new segment out, it's going to go through Alluxio with this mode cache through, will basically hold it in memory, but then also flush it down to the underlying file system. So you want that. There's an async through mode in 1.6 that I want to try for a little bit of speed, but you'll see in a second, like that overhead of going through Alluxio first ended up being nothing, right? Like it was less than 1% difference than just writing to the local SSD anyway. So I thought that was kind of cool. This one really got me excited when I first saw this feature. Was so basically an admin can pin a specific index directory or a specific file in Alluxio, and this is cool because, especially for like e-commerce customers, I apologize, I'm losing my voice, as I'm sure many of you are after this week. You can say like, this index is really important, so I'm going to pin it and keep it in memory and keep it, you know, basically as hot as possible in Alluxio. Whereas these other directories, they can fall down to tier storage and be slower. I don't care, but this one this one index, super important. And so that's this idea of pinning, which I thought is cool. And if you think about it, like Solr relies on the OS cache to do the right thing a lot of the times. With Alluxio, you have complete control over basically the OS cache, right? And what stays in memory and whatnot. You don't get those controls with the OS cache. You just kind of hope that it does the right thing. But with this, you actually get that full control. Another nice thing that I like is they support TTLs. So again, you can say, this data has a time component. It's going to age out, and I have a use case for this in a sec. So briefly, in say a week, don't keep this index in memory anymore. Let it fall down to slower storage, right? And so that's pretty cool too. And you just set it and it just happens. Like you don't have to worry about managing it and those kind of things. I know a lot of people have hot, cold storage type scenarios they've cooked up, right? I see some heads nodding. Well, this just kind of does it automatically, right? You do some initial setup and then bam, it works. And then the other nice thing is like, if you have data, like I said, remember, you don't have to move data. You just mount an under file system and then you call a load command and that'll pull that up into memory, right? And so let's look at a first use case. And this is more me just wanting to make sure before I get up here in front of you guys, Solr people, that like, I'm not kidding myself that, you know, this doesn't work or something, right? So I basically just fired up on EC2, I think it was our R4X large, which has 4 CPUs, a decent ton of RAM, and then basically I have this little performance testing framework that I have. So I did indexing. I only did 5 million docs. Obviously, you want to do more and more scale testing and all those sort of things. But I did 5 million docs. I got 4,000 docs per second, and that's going through Alluxio. And I got basically the same speed as Alluxio for indexing as I did just going to the local file system. So that cache through overhead is very minimal, which I thought was pretty cool. I was expecting some kind of difference, and actually those CPUs when I ran this job were peaked. I mean, my load average on that box, everything was really high. You know, 1,000 docs per second per core is kind of what I've seen in EC2, so that makes sense. So query performance. Query performance is more interesting. First off, I'll talk about this column on the right. other than you, nobody else is running this. But as I said, I always liked it from an architectural perspective, but I never really quite liked the performance hit. And obviously not big data, but I was able to get basically 20, like a kind of a, queries per second, sustained rate. I think I execute like 10,000 queries or 20,000 queries, 20. My max time was 6 seconds, or 5.6 seconds. That's not good. Standard deviation, median queue time, that's decent. We can all live with that. But some of the upper percentiles, like I know you can't probably roll with that kind of percentile. Whereas then I said, okay, well let's just do mmap, right? Like this is what you do normally if you're not using cloud storage. And it did 42, so that was pretty cool. These are randomized queries, so I probably have some crazy queries in there that are hitting these maxes. But I think it's more the comparison of the numbers, right? That's really nice. That's a little sketchy. And then if you look at Alluxio, it's not quite as fast, right? And if you think about that, well, that kind of makes sense because there is some overhead of going to Alluxio, right? Even though the data is in memory, it's not going to be as fast as mmap, right? But it actually wasn't that bad. If you look at it. It's pretty close to this. And you get now all of the nice things like pinning and TTLs and all those great things. And as you're going to see in a second, you get some other cool stuff. And by the way, this is not like the most scientific of experiment, but it kind of gives you a rough idea. Okay, so use case 2, and this is where I think it actually starts to get interesting. Like that first one, I don't think you'd actually probably run Alluxio just doing local file system stuff. This seems like too much overhead in another system to manage. But where I think it gets interesting is you want to use some sort of cloud storage, right? And these cloud vendors are spending millions of dollars and researching and investing and building these amazing cloud storage platforms. But what's the problem, right? The problem is it's too slow for Solr. If Solr has to go to S3 over the wire every time, like it's not going to perform to what most people need. As I said earlier, I actually couldn't run that experiment because I couldn't get Solr to work with S3. So unfortunately, I don't have the numbers on that, but I'm pretty much going to guarantee you it would be a lot slower. Because even local HDFS was slow, and going all the way out to S3 for Solr would be terrible. So now look at the indexing rate here. So it dropped down to 3,600 to go to S3 from the local. This is all the same hardware, same data, same everything. Which that's not too bad. That's a 10% drop, right? We could probably live with that because now our data is out in S3, and I'll show you some recovery scenarios that I think make this really cool. And this is what I expected, and it actually worked out, right? Is like we expect, because now data's in memory, that our performance is going to be the same. Even though my index is in S3 with Alluxio, my query performance was almost identical, right? Like it didn't change that much, which is what we expect. So I was happy to see that. Actually, I'm just showing you. To mount S3, and this is my little bucket that I keep track of. You just do mount, and then obviously there's S3 credentials you got to set up and all that business. But once you do that, you just mount your S3 bucket to some path in Alluxio, and boom, you're done. Like you're running on S3, and I could show that, but we'll keep moving on. And then the other nice thing is, I think Google Cloud Storage does as well. They don't call it quite ephemeral storage, but it's not, it's the same basically. When you spin up certain instance types in EC2, you have the option, like R3s, for example, have two, I think it's one or two, instance stores, just one, okay, thank you. That they're actually pretty wicked fast SSDs, right? But the problem is if that node gets terminated, or that instance gets terminated, that data is gone, right? But what's cool is that with Alluxio, they have this idea which is called tiered storage. So basically memory is the top tier, and that's the fastest. But you can basically configure it to say, if say a directory got freed up from the TTL, or we're just running low on memory, let me fail down to the next tier, which would be SSD. So you can take advantage of these ephemeral storage drives that actually I don't think Amazon charges you that much more for them, right? Like they're pennies per per hour, if that. And so it's like, I always like using them, but I always hated the fact that like if that instance terminates for whatever reason, they're gone. And so think about this, like you can't basically run a production Solr on that unless you're really relying on Solr's replication all those times. I mean, you could do it, but the nice thing with this is like your data is still always going to be in S3, and so if you lose an instance with ephemeral storage, who cares, right? Spin up a new one, point it at the S3, and you're golden. And so I thought that was actually really cool and a nice sort of feature to flow out of this. And then as I mentioned, like, again, you can get back to these pinning of specific, but I already mentioned that, so we'll move on. Here's another use case that I think Alluxio fits really well with is time-based partitioning. In Fusion, we basically have this feature where you can say, my data has a time, it's basically kind of has this time component. You can think of clicks, click logs and various other like search logs and those sort of things. And you can partition them by time, okay? And the idea here, like, as I'm showing, today's partition, yesterday, and whatever. You probably wouldn't be this aggressive, but the cool thing is you'll now have, you can basically have your partitions, more recent data, and the use case there is basically a lot of the queries and the performance you're looking for is more on recent data. And you need to go back into older partitions sometimes, but put the emphasis on the more recent data. And the other nice thing is that once these partitions, if you're doing this strategy, usually you're doing it because it is kind of like logs where it's write once and then they're immutable, right? And so you can basically say, I want my recent partitions in memory, and then I'll set up tiered storage so that as they age out, and you just set up a TTL policy in Alluxio to say, age this out into tiered storage, so they'll automatically like fall down to SSDs, or if you have HDDs, and basically Alluxio will manage all that for you, keeping the data in hot and cold storage, which I thought was actually pretty cool. And then what's nice is a lot like what Noble did for Solr is they have these plugins where you can have your own custom allocator and evictor policies. So you can get really fancy with like, how do I move data around in between tiers and things like that as data ages and whatnot. And they have really nice pluggable strategies for that. So I thought it was actually pretty cool. Okay, so this is not really a use case, but I probably copied that slide. So imagine now we're running out in Amazon. I know EC2 best. And let's look at like a cloud-based recovery scenario, because this is where I think it really gets pretty cool. So we're running and node 1 goes away, right? Like it goes down for whatever reason. Solr has this built-in feature, auto add replica, right, when you're using the HDFS thing. And the reason for that is, right, is because the actual data is on S3, right? It's not on that node. It's in memory on that node, but it's elsewhere as well, is a better way to say that. And so what happens is you can configure Solr to say, well, I need a replica for this shard. So the overseer is going to go ahead and do this add replica command. And I apologize, it's not totally accurate. But for this talk, it adds that replica out on a new healthy node. And in this case, notice that I'm actually cross AZ too. So this is where it also gets very cool. I see a lot of people wanting to run Solr cross AZ. Case maybe US East 1D went down there, right? But C is still up. So Solr adds that. And what happens is basically that replica is going to say, presumably you also have a Alluxio worker there, is going to say basically, let me start serving traffic out of this index in S3. So it's going to go to Alluxio, and Alluxio, if this is a brand new node or whatever, will just be like, well, I got to go out to S3 and pull the data. But it's going to pull it through and actually start caching in memory and all those nice things. What's cool here is that data didn't have to move. So one of the things I really don't like about trying to auto-scale Solr and things like that is if you bring up a new replica because you need more hardware in the cluster, without this, you have to do, thank you. without this, you have to do this big snapshot pull. And it's not a big deal on these type of networks if the index is small, but if you're doing a huge snapshot pull of like this massive many gigabyte, I've heard of terabyte shards and things like that, you're in trouble, right? Like you're trying to bring up new hardware to deal with an undercapacity problem, and yet now you have to wait for this huge download and all these kind of things, and if it's a busy cluster, like you have to buffer the updates and all these things. So that moving of that data is still a very big problem in Solr, I think. Noel's not nodding. Okay. And then the other thing, I think, if I was going to set all this up, and this pretty much just works out of the box with Alluxio, but is to have some auto warming and caches configured. And the reason for that, I think, is that basically you want this replica to be hot and ready to go, and data cache through Alluxio and things like that, basically once it's marked as active. And we actually found an issue at one of our customers, and of course Shalin came in and fixed it. So Solr 60886 was, the replica used to mark itself active in the cluster before it was fully warmed. And so what would happen, again, right, like your queries are kind of blowing out the SLA, so you need more hardware, and then you come in and bring this cold searcher in and start routing traffic to it, right? That just makes searches worse. So he fixed that, and I think for this scenario, it works really nicely. Okay, this one I won't spend much time on, but actually I think it's pretty cool. With Solr, and you've probably seen this in a number of talks, is like more and more with especially Solr streaming expressions, you can do a lot more than just the top end ranked fast queries with Solr, right? Like these streaming expressions allow you to pull massive result sets, do all this analytics. And so especially at Fusion, at Lucidworks, we're starting to see this mix of analytic workloads in Solr, as well as obviously, the bread and butter top end ranked queries. And so we're mixing Spark and things like that. Alluxio really kind of started by the same folks as Spark out of Berkeley. And so a lot of people use Alluxio to speed up Spark jobs, especially iterative ones like ML jobs and like big, jobs that have huge DAGs that basically take data input from one job and feed it to the next and things like that. Alluxio is great for that. So I just want to mention, like, in addition to running Solr and all the cool things we saw, you also get all these kind of benefits for doing ML jobs and analytical jobs and things like that. So if you're interested in that, check that out. Okay, so as I mentioned, work in progress. Alluxio 1.6 is RC1 now. It's being tested. I'd imagine it's coming out soon, but this is the bug I found. I actually didn't find it. Some HBase guys found it. But this affected us, and so there was that temporary workaround, but it's fixed in the 1.6. So if you did, I would just start with 1.6 RC1. Still having problems with these orphaned write locks in HDFS, kind of a known problem. I've seen some people just say, well, don't run with a lock. I've never done that, so I don't know if that's wise or not. I opened this Solr ticket about closing the file system object retrieved from Git. That's just kind of like a no-no in Hadoop land, so I'm surprised Solr does that. So I've got some questions out to some people that know more about these things than I do. 6237, I think, is probably the coolest one on this slide, which is essentially, the idea is, and again, you have to have something like a cloud storage or whatever, is you write to the leader, and instead of the leader now, as it does, right, it forwards on to the replicas, and they do their own indexing job. The leader just indexes, and you tell the replicas, share your data off this leader, right? And so your indexing performance goes up huge because replication overhead in Solr is still very high. And so I think this, basically 6237, was a little bit on hold while we were doing the new replication types and things like that and getting that sorted out for 7. But now that's all done, I think it's prime for doing this. I've worked with Mark on a little bit, so we'll probably take that back up, because now, especially with the Alluxio thing, I think, imagine this is that basically you're sharing the one index, but it's in memory on all the workers around your cluster, right? So you're getting a really nice benefit of all the cloud storage replication. You're not paying this extra cost of replication in Solr, and you're getting all the performance benefits on the query side. So this to me is very cool, and I hope to be able to get more time to work on that. And as I mentioned, I couldn't get Solr running on S3, class path issues, and I mentioned test async. That seems a little dangerous for Solr, because again, what it does is Alluxio is going to cache it and then get around to putting it down on the file system. So that may be more dangerous for some people, but for like a logs collection, that might fly. Okay, so I tried to take a stab at what questions might be coming up, but I'll rip through these and then we'll have like 2 minutes for questions. Sorry guys, I talked more than I thought I would. So does it support running in HA mode? Yes, I mentioned that. Uses Zookeeper. So data locality, right? How does this work? So effectively, Alluxio kind of comes out of the box that it will essentially see that the Solr is requesting data from a worker that's on the same node, and it'll just kind of do the right thing. If you do writes, and this already works in HDFS, this is how data locality works with HDFS, is the replica that receives the writes will write to HDFS, and HDFS basically keeps those blocks on that node, right? And so that's how you get data locality. It works very similar in Alluxio. The one difference is you actually have more, I'd say sort of policies, pluggable policies about data locality in Alluxio than you do with normal Hadoop and things like that. So for as far as I could tell, it works well and it was well thought out, but probably more testing there at scale. What block size, right? Because again, we're dealing with these type of systems, for example, HDFS that has blocks and recommend for Solr. I only put this on there because I set a small block size and then merged together a segment and it blew out the block size. So the default is 512 meg. You may have to tweak that a little bit because of merging and how you do your merging and things like that. Again, I mentioned the overhead of cache through during indexing. It's negligible. Solr's block cache, so that's another part of HDFS. Since you guys aren't using that, I won't get into that much. But there's a bug right now, I think. It's either Alluxio or Solr, I'm not sure. I'm looking at Solr, I'm working with the Alluxio guys. Think about this. Block cache sort of keeps these caches, these blocks out of HDFS in memory. So my first thought was, well, let's turn that off, right? We're using Alluxio, so it's already in memory. Let's turn that off. I turned that off and performance got really bad. So I was like, oh, this doesn't seem right. So that's still an open question that I need to figure out. Ideally, you would turn that off because you don't want all these crazy caches, right? Like it's good to just have one solution for one problem. And then lastly, does Alluxio work with Solr 7? Unfortunately, no, but it's an Alluxio problem. They've created this client jar that has an incompatible version of metrics that compared to what Solr uses. So, and I actually tried to hold up the RC voting because of that, and then it turned out to be these guys' problem. So try it with 6.6 for now if you're interested in this, and then we'll figure something out for 7 real soon. Questions? Older version of Solr? Yeah, sure, it works with that. No problem. Because, I mean, HDFS directory factory's been around for years, right? So, yeah, you'll be fine. Dave.
So I can see how this works great when your index is small enough that can kind of fit in memory. This seems to use memory a lot. But what if, like in the logs case, we recommended it in logs, but typically your logs might be very large at log search, and then you might have only so much RAM on your machine. So, like, does Alluxio with Solr still work in cases when you have very large indices and your memory is, not massive?
Yeah, so it has the idea of, first off, it keeps track of which files are really used and things like that. So it works a lot like the OS cache, right? This is almost like the same problem as the OS cache. You just have a lot more controls. The other thing is, it has that idea of tiered storage. So you can set up and say, well, let me leverage my SSDs and things like that. So it prefers memory, but it can use other storage layers as well, which is nice because a lot of, I've seen people time and again wanting to use some network storage device, right? Because they've invested millions in it. It's like, why can't you use Solr on that? I'm like, because it's not going to work. So And then as far as like the logs use case, that's where I think the time-based partitioning comes in. Like, it makes sense to have smaller indexes per partition. I mean, that maybe doesn't work for everybody, but that's how I solve the big giant logs collection problem, is the partition. And I think that's a better strategy than just having this massive thing. The other thing I'll say is, like, RAM's pretty cheap, like, compared to what it used to be in those sort of things. So, like, I know, like, a lot of people still kind of cry about RAM or whatever, but, like, I seriously have customers that have, you know, a half a terabyte of RAM in, like, 50 nodes. Like, they don't care about RAM. Like, RAM is cheap to most people. So, so it kind of just depends on who the customer is, right? You want fast search, you know, RAM is a pretty good way. Like, you know, I guess it's kind of one of the more cost-effective ways to actually get really, really fast speed, is just to buy some more cheap RAM. So, and I'm not being glib about that. I know some people you don't do that, but a lot of people are running on pretty serious hardware that has a lot of RAM that's actually not really taking advantage that well. I have probably, am I done? I'm done. All right. Thanks, everyone. Appreciate you coming.